Good day to you all. You are welcome to today's lesson. Today we'll be looking at a question on quadratic inequality. What's quadratic inequality? That is a quadratic expression having inequality sign, which are greater than, less than, greater than or equal to, or less than or equal to. Now the question is, show graphically the solution set of the inequality x squared minus 7x plus 12 greater than 0. Now, how do we solve this? The first thing you need to do is to factorize this quadratic expression that is there. That will give us this multiplied by this, and that will give us plus 12x squared. Then we look at the number that number that we multiply them together to give us plus 12x squared, and if we add them to give us minus 7x, and that is minus 4x multiplied by minus 3x, or minus 3x multiplied by what? Minus 4x, any of the two. Then we'll come here, x squared. We replace this one at the middle with these two factors. That will minus 4x minus 3x plus 12 greater than 0. So then this, you factorize these two. X is common, that's x into bracket. X squared divided by x squared, that is x minus 4x divided by what? X, that's by minus 4. The first thing that is common in this is what? The sign, which is what? Minus. Then also 3 is also common. 3 minus 3 divided by minus 3 will give us x. Plus 12x divided by minus 3 will give us minus 4 greater than 0. So the first thing that should I correct, the one inside here, one they are the same thing, then you are on the track. So we pick one of them, that is x minus 4. While the one outside, we pair them together, that is x minus 3 greater than 0. So from here, what we are going to do here is that we are looking for the value of x, that when we input it in this expression here, we are going to have answer that is what? Greater than 0. And how do you do that? Let's take a recall in our quadratic equation. If this thing is x minus 4, x minus 3 equals to 0. You know, if it's quadratic, we are going to pick x minus 4 equals to 0 by equating each of them equals to 0, or x minus 3 equals to 0. Then this come here, x equals to 4, or x equals to 3. That's what you are going to do. So in this one too, we are going to follow the same procedure, but a little bit different now, which is instead of us having equal to, have equal to, you are going to have what? The inequality sign, which is what? Greater than. So that's what you are going to put into consideration to determine the value of x that will satisfy this expression. That will give us x minus 3 greater than 0, or x minus 3 greater than 0. Then we solve the, if this minus 4 come, you are going to have x greater than 4. Then if this minus 3 come to this side, x greater than 3. Now we are looking for the value of x that will satisfy this. And how do you do justice to that? Get the range of value of each of them. That means x is greater than 4. What are the numbers greater than 4? We have 5, 6, 7, and continue like that. So what are the numbers greater than 3? We have 4, we have 5, we have 6, and continue. Now, we cannot pick the two greater than. What we need just one out of these two. And that is the essence of listing their range of values. So we are picking anyone that will satisfy this. So you can do what we call try and error. Be inputting the value of x here. Let's try 5. Let's put 5 for the first one. That becomes 5 minus 4, which is 1. Then put 5 here again. 5 minus 3. That will give us what? 2. We have 1 here. 1 times 2. It will give us what? 2. Is 2 greater than 0? Yes, correct. Let's try the second number, 6. Let's input 6 here. That was 6 minus 4. That's 2. Then 6 minus 3 here. That gives us what? 3. 2 times 3, that is 6. Is 6 greater than 0? Yes, correct. So But for us to now conclude that okay, it is when S is greater than 4 that will satisfy this inequality expression. Let's type the other one that we have here. Let's type 4 again. Let's try 4. Let's put 4 for x here. That will give us what? 4 minus 4, 0. Let's put 4 here. That 4 minus 1, 1. So the 0, we have a 0 here, we have 1 here. 0 times 1, that is what? 0. That means we are going to be having a 0 greater than 0. Is 0 greater than 0? No. 0 is equal to 0, not greater than 0. So which means the one that will the value of n that will satisfy this one is when x is what? Greater than 4. So out of the two greater than that, the correct one that will satisfy this inequality expression is when s is greater than 4. So the next thing was to get the second value of x. Because it's a quadratic expression, you are going to have two values. So to get the second value, the only thing you do now is you change the inequality sign. So that will become x minus 4 less than 0 this time around, or x minus 3 less than 0. So we solve it again. X is less than 4 or x is less than 3. So now, to know which one to pick out of these two again, you use the range of value of x. So the range of value of x here, number less than 4, we have that's 3, we have 2, 1, and it continue like that. The number less than 3, we have 2, we have 1, 0, and it continue like that. Now, let's try it as well. Let's try the first value, which is 3. Let's say put 3 in this place. 3 minus 4, that is minus 1. 3 minus 3, that is 0. 0 times minus 1 is going to give us what? 0. That means you are going to be having 0 is greater than 0, which is not. Let's try 2 again to be sure. Put 2 here. 2 minus 4, that is what? Minus 2. Then 2 minus 3, minus 1. Minus 2 times minus 1. Minus 2 times minus 1 is going to give us what? 2, which is greater than 0. But because this first one cannot satisfy this expression, so we cannot use this. So this cannot go. I didn't make this first one satisfy, then we can proceed to use it. But because the first digit cannot satisfy, that means s must never be what? 3. So which means this second one here, you can see that the first value here is 2. And when I try to 2 work, so which means this will satisfy this expression when s is what? Less than 3. So we can see that the first digit was able to satisfy. Just like this one too, the first digit was able to satisfy this expression. So that's how you can easily know once the first digit is not giving you, don't bother to say that means that word place cannot work at all. And besides, once you say that this one, when I pick it, the one in my right hand side, left hand side satisfied it. So that means the opposite one will be satisfied, or you can really test it yourself to determine which one can satisfy the expression. So that means the some value of it that was that word x is greater than 4 and x is what? Less than 3. They are the one that can satisfy this expression, and that can be combined by saying which is from here 3. The sign is facing 3. That 3 is greater than x, while x is greater than 4. That is a combination of the two. Now to now represent it, you do your number line. You can represent it in your number line first before the quadratic. That will be this one. We have this 0, this 3, this 4. So because the two, they are both positive. The first one says x is less than 3. X is less than 3. You go like this. While the other one says x is what? Greater than 4. You go like this. So any number at this side can satisfy this expression. Any number at this side can satisfy this one, the expression. But in one within cannot satisfy. So that's one way to show this graphically. Then another way to show it graphically is using our quadratic graph. And okay, let me manage to use it. Using the quadratic graph, I'll just do like this. still the same thing. 0, 3, and 4. Now, you look for the coefficient of what? X squared. The coefficient of x squared here is 1. So, and once your a is greater than 0, the sketch of the quadratic graph will what? U shape. But if your a, which is coefficient of x squared, is less than 0, the coefficient of, the graph of the quadratic become what? N shape. So our coefficient of x squared here is what? Greater than 0. So you are going to have U shape. So I'm going to have something like this. U. Now, when you check the linear, the number line graph, you can see that x less than 3 go this way. Why this one go this way? That means they are not meeting. They are going in separate direction. So if they are meeting, I will shade this inside. But if they are going in different direction, then I will just do like this. Like this. This one telling us that it is less than. Now we'll do the same thing here. This telling us what is greater than. That means the value, the something don't meet. So if they meet, I'm going to shade them. But if they are not meeting, I'll shade the outer part. So that is either we have this or this. That is the representation of the solution of this inequality graphical. If you enjoyed this video, don't forget to share to your friend, subscribe, and keep sharing. See you next video. Bye bye.